Okay, so we're going to look at how you work out the number of atoms or the number of ions in a certain number of moles of a compound. So we're going to start with the compound magnesium sulfate, MgSO4. You remember magnesium hopefully is +2, and the sulfate ion is -2, and therefore the whole thing is neutral. And if you're not sure, look at H2SO4. H is +1, always is. Pretty much, and SO4 then, if there's two H's, must be -2. So we're going to look at magnesium sulfate, and I'm going to tell you, I'm making this up as I go along, that I've got 2 grams of it, 2 grams of magnesium sulfate, the salt. So let's take a little look at what's going on there. If we can just move that out of the way, stick it up there, and have a look first of all. Okay, so in magnesium sulfate we have 1 magnesium. Okay, so that has a relative atomic mass of about 24. I'm going to round for this. Obviously, you would use the value on your periodic table. So we've got 24. Then we've got sulfur. That's about 32. So if I do this in my head, we get to about 56 there. And then finally, we've got oxygen, which is 16. So we're at 56 for the first couple. And then we're going to have to add oxygen 4 times. And why is that? Because it's MgSO4. There's 4 of them. So let me just do that, 56, then plus another 64. It's maths, I can't do it in my head, so bear with me while I just calculate that. I can do it in my head, but I know I'm going to mess it up if I do it off the top of my head. So here's the old calculator. So let me just make sure, 24 plus 32 plus 16 plus 16 plus 16 plus 16, and all those 16s is 64, gives me 120. So the MR, where do we write that? The MR for magnesium sulfate is 120 grams in every mole. Okay, so that's where we're up to so far. Let's get rid of these. We actually aren't going to need them, but we'll shove them up here just in case. Might be quite nice. Let's draw a little 4 there. Can we draw a little 4? Yeah. There we go. Magnesium sulfate, MgSO4. So you know from the equation, N equals M over Mr. Let's pick a nice green colour to do this in, I think. So let's go with that, nice green. So N equals M over Mr. M over Mr. Okay, so we need to know the number of moles of magnesium sulfate. So we know that the mass of it is 2 grams. That's this value here. And we know that the MR, we just worked out, is 120. So 2 over 120. Now I've still got my calculator out, so I'm going to do that. 2 over 120 gives me 0.017. 0.017 moles. Okay, I could have picked a nice number, but I decided not to. So let me see if I can get rid of this, make some of this a little bit smaller, so we've got some more room. That's about all we're going to need there. 0.017 moles of magnesium sulfate. So there are a few different questions we could be asked now. I'm going to get rid of that altogether, if I can. There we go. They might say to you, okay, how many magnesium ions are there? We'll go for a pink. So, magnesium. That's terrible, terrible writing. Let me write that again. I can't. I've messed it all up now, so I have no idea what I'm doing. There we go. Get rid of that, and get rid of that. It's been a while since I've really fiddled with this. So we've got Mg. Let's say we want to know the number of Mg ions. Well, we've got 0.017 moles of magnesium sulfate. And if you look at magnesium sulfate, in every single molecule, there is 1 magnesium. There's 1 sulfur, and there's 4 oxygens. So you could kind of think of it as a ratio of MgSO4 to Mg to S to O. So let's take a look at that. Well, how does the ratio work out? Well, for every MgSO4 molecule, we get 1 magnesium, 1 sulfur, and 4 oxygens. So, really simply, if you have 0.017 moles of magnesium sulfate, you have 0.017 moles of magnesium ions, 0.017 atoms of sulfur, and, well, not 0.017 here because we've got 4 oxygens in every one. So it must be this value multiplied by 4. So that's 0.034 is by 2, 0.068. So we have 0.068 moles of oxygen atoms. So let's carry on. We're going to have a real crack at trying to delete as much stuff as we can here. And there must be a quicker way to do all this, but at the moment it's deleting one by one, so let's do that. And let's carry on. So let's try another example. I really am going to make this up off my head. Let's do Na2CO3, I think that's correct, sodium carbonate. So Na2CO3. And I'm going to need to work out the total MR of this. So the MR is going to be, well, I've got sodium. Sodiums are worth 23. So 2 of them is 46, then the carbon is worth 12, and then the oxygens are worth 16 each, which is a total of 48, and if you sum all those together, you will get 106, let's just write that in there, grams per mole. So if I had 5 grams of sodium carbonate, I could work out the total number of moles, so N equals M over MR, and this time it's 5 over 106. So again, on the calculator, and I'm really not picking nice numbers, gives me 0.05, or close enough, if we round to 2 decimal places. So that's the number of moles I've got of that. Okay, so what can I find out then? If we can just make that smaller. So, if I've got 0.05 moles of sodium carbonate, well, let's look at what's going on. Maybe they'd ask me how many moles of sodium. So I'm going to give you a second to think about it. How many moles of sodium are there? The answer is 0.1, if we get the pen. So for sodium, the answer is 0.1 moles, because it's double the number of moles of sodium carbonate. For carbon, it's 0.05 moles. Finally, for oxygen, let you do this one. It is 0.15. So what if they asked you about ions? What if they asked you the number of sodium ions? Well, the number of sodium ions here is double the total number of moles. Total number of moles is 0.05. So the number of sodium ions is this, that's fine. But what about if they asked you the number of carbonate ions? CO3, 2 minus. What if they asked you how many of them there are? Well, if you look at sodium carbonate, there is only 1 carbonate for every total molecule. So it's a 1-to-1 ratio. There is 0.05 moles of sodium carbonate, therefore there is 0.05 moles of carbonate ions. Finally then, let's just go through and summarize this. This is maybe the longest video I've ever done, so if you're still with me, you know, I appreciate it. My example the other day was a bus. So let's draw that bus. There it is. And here is one guy. He is from, I don't know, let's say Pakistan. And there's only one Pakistani guy on the bus. There are 100 people on the bus. But if I told you I had 20 buses, then you'd say to me, okay, that means you have 20 Pakistani guys. If we get rid of the bus, we can do another analogy. Come over here. If I told you that we had a cheesecake, I do like cheesecake, and there was always, I don't know, let's say 1, 2, 3, 4, 5, 6, 7 strawberries on it. 7 strawberries, is that 7? Yeah, 7 strawberries in every single cheesecake, just like there's 3 oxygens in every single sodium carbonate. So if I told you that I had 20 cheesecakes, there would be 20 times 7 strawberries, which would be 140 strawberries. So, you know, all you've really got to do to work out the total number of atoms or the total number of ions is figure out how many moles of the molecule you've got. then figure out the ratio of that molecule to the things inside it. And from there, it's pretty straightforward. You know, if you have CO2, say you have 5 moles of CO2, that means you have 5 moles of carbon. But because with oxygen it's diatomic, and well, it's not really diatomic, it's the wrong word to use, but because there's 2 oxygens in every carbon dioxide molecule, that means that there are 10 moles of oxygen. Hopefully that helps. If you're still with me, fair play to you, because I'm not sure I would want to listen to myself for 10 minutes, but I hope that that was of some assistance. Take us there. There may have been a little gap in the audio there, but we're on a new slide.